Pre-flight 101, the course that will give you wings. 5. Aircraft systems and structures. 5.5. Engines and the oil system. Hey guys again, nice to have you here. Through this lesson we're going to learn about the power plant of the aircraft. As we have mentioned before, each variant of the Cessna 172 we're studying carries a different kind of engine. We will comment the small differences between the three of them, and after that we'll focus on the oil system. The oil system is really similar in the all variants. However, there are small details I'd like to show you. So now this is the Cessna 172 November engine. The Cessna 172 November, as you might remember from previous lesson, carries a Lycoming engine, the A320 Hotel 2 Alpha Delta. This engine just produces 160 HP at 2700 RPM. There are two major accessories added to this engine that weren't there before the Cessna 172 November with this Lycoming engine. These are the starter motor and the alternator belt. Okay, we didn't have that before. It was a big improvement. Before you had to actually pull your propeller by hand to start the engine. In the cockpit we have two engine levers, as we have talked about before in the fuel system. We have the throttle, we have the mixture control, and as you can remember, they are both connected to the carburetor to control the ratio of fuel and air going inside of the engine, thus creating that thrust that we are asking the engine to produce. All right. They usually work the same in this kind of planes. If you push them fully forward, it opens the throttle to the maximum, and if it's pulled all the way back, it's going to cut the throttle closed. The mixture level can either be rotated. For minor mixture adjustments, you can just rotate the red cap slowly. Imagine you want to trim your mixture just a little bit, you want to cool your engine just a couple degrees, so no point in actually doing big moves, so we're just gonna rotate it. If we need big movements, fast movements of mixture, such as in a I don't know, we want to get full reach or we want to start the engine, we can push the button that is in the middle and do this big adjustment we need to do. Right, so this is the Cessna 172 November magnetos system. The magnetos in this engine are arranged in cross, and there are two spark plugs, as we can see, spark plug 1, spark plug 2 in each cylinder. This means that the left magneto is going to fire the lower left and upper right spark plugs, as we can see in the picture. But in normal operation, however, they both will operate simultaneously. Again, this magneto is going to be powering the right upper cylinder spark plugs and the lower left cylinder spark plugs. That's how it's going to work. The others want to do the exact opposite. That way, if a magneto fails, you're gonna go to lower RPM, but you're not gonna lose a complete cylinder, therefore you're not gonna lose your engine. That's what we're looking for with this kind of weird system. The inlet air comes from the manifold inlet in the front engine cowl. Then it's filtered in the air filter and pushed into the carburetor. In the carburetor, there's a carb heat system. This system is going to close the normal air intake and open a heated air in order to heat the carburetor. We said before something about this system. So the carburetor engine is a nice and simple engine, but had a really bad drawback. Some pilots were experiencing something called carburetor icing, right? When the carburetor was too cold and the outside air was too cold, the carburetor actually froze inside because of the venturi that was creating inside of the carburetor. Therefore, we had to heat it. So the only way to heat it was to throw some hot air inside of the carburetor. we're gonna see now that the use of the carburetor heat is gonna be explained in just a bit. However, we can anticipate that the use of this carburetor heat is gonna lower your RPM by 100 or 200 RPMs. That's the normal range of operation of the heater. The exhaust system has a muffler combined with a heat exchanger, as we can see here in this picture. This heat exchanger is going to be used to heat the cabin air and to heat the inlet air for the carburetor heat. So where can we get hot air? In the exhaust. That's air that's just gonna go to waste. But yeah, this sounds weird to you. You are probably saying, well, what is this man saying? Obviously, we don't put exhaust air inside of the cabin or exhaust air inside of the inlet again. Of course, we don't do that. This box right here represents the muffler. There's a heat changer, right? So the hot air from the exhaust is coming out. The blue, nice inlet air that is clean is coming from the atmosphere, is coming through the inlet, is going to be mixed with this exhaust air. Therefore, it's going to be throwing nice warm air inside the cabin or the carburetor heat as required. But of course, there is no exhaust air mixing with cabin or inlet air. As we can see here in this picture, this is a nice representation of the Cessna 172 November. There is also a primer. We have already talked in the fuel system section about the primer. It's basically, in this case, a manual pump that is going to be taking fuel and injecting it into the manifold next to the cylinder. This system is used, as we said before, in cold starts. And yeah, the cooling of this engine is going to be performed just by using ram air coming inside the engine by the front. Otherwise, the Cessna 172 Romeo is powered by an injection engine. Just like its predecessor, it's still a 4-cylinder boxer arranged engine, right? That means that we have 4 cylinders, 1, 2, 3, and 4, and they are arranged horizontally opposed or in boxer configuration, right? This engine is the Lycoming India Oscar 360 Lima 2 Alpha, as you might remember from the first session of the systems course in this part. And the controls we have in the cockpit, they are going to be the exact same as we had in the Cessna 172 November. We have the mixture lever, we have the throttle lever, and they are going to be operated exactly the same way. In the case of the Cessna 172 Romeo, the instruments feature are basically the same as in the Cessna 172 November. The only difference, big difference of course, is that it's going to be featuring the Garmin 1000. Oil pressure, oil temperature, a tachometer, and an exhaust gas temperature indicator. These annunciators also will feature a red indicator or a red light, right? Red flashing light in the advisory section of the Garmin 1000 that is going to draw your attention if the oil pressure is too low, right? About less than 20 psi's. With less than 20 psi's, your oil pressure is way too low. Something's definitely wrong. You're gonna get this advisory. These instruments are electric, so they require an electrical source to transfer information to the indicators. And yeah, just a curiosity for you, the hour meter in this case is connected to the oil gauge. It's going to be counting hours, counting engine hours automatically every time the oil pressure goes above 20 psi. The EGT indication we have down here. The EGT or exhaust gas temperature is useful to lean the mixture or adjust it, as we will see in the procedure section. Don't worry about it. And also the magnetos in the system are exactly the same as in the Cessna 172 November. You can take a look at that slide again if you want. As you can remember, they are opposed. So if we have a failure in one magneto, we don't lose the whole cylinder, and therefore we won't hurt or lose the complete engine. Okay. Now, as we can see here, this is the same drawing as before, but there's a small difference. Here we don't have a carburetor, therefore the warm air that is going to be transferring from the exhaust to the inlet is only going to go to the cabin heater. So yeah, obviously again we don't have cross bleeding in the system, and the rest of the system basically remains unchanged. The big difference is that one is a carburetor engine, the other one is an injection engine. Therefore, everything related to carburetor disappears, but we have some more instruments related to the injection engines. And finally, Cessna 172 SP for this presentation is going to be featuring a diesel engine. This diesel engine usually features a big amount of substantial changes, as we said before. In this case, it's a 4-cylinder turbo diesel. This means that we are fitting a turbo or a supercharger. These are two machines. In this case, we're using a turbocharger. It's basically a machine to increase the inlet pressure. Okay, more pressure, more power, or more efficiency in the engine. Okay, I don't know if you guys have done some kind of aircraft general knowledge class already. You will get this explained probably. For now, you just need to know that it is a device to increase the power of an engine. Okay, they are usually not fitted in gas engines. They are only fitted, not only, but they are commonly fitted in diesel engines. Not every engine can cope with the pressure or the strain that this turbo is gonna create on the engine. Okay. Anyway, it's a common rail, so the arrangement is a bit different than the rest of the engines. Direct injection, again, obviously we don't have a carburetor. Carburetor and diesel engines don't match too good together nowadays. It has a redundant FADEC. We have talked in the electric section about the FADEC and what it is, what it controls, again and again. And it's basically a 155 HP at 2,300 RPM engine. It's going to be turbocharged, as we said before, and a really big point here, it's water cooled. Okay. Another big change between the two previous engines and the diesel engine is that instead of being cooled by the ram air just coming inside and touching the engine, it's cooled by water. This water will cool the engine by a radiator or a heat exchanger and disperse that heat into the ram air, just more or less like it happens in your car. Okay. Also, instead of the typical key control, this kind of engine features a master switch. Okay. It's going to be around the left corner of the side. We will have a master switch kind of around here. And it's also going to energize the FADEC. We talked about this again in the electronic section, really big on the FADEC. If you want, you can go back and review it. And then we have this button right here, that is the start button. With the master, we give the FADEC the carry that we want it to start. And with the start button, we want the FADEC to start the engine. He's gonna take care of everything. Okay, another significant change is that there is only one lever. As we can see here, there is only one lever, as the FADEC is going to manage the mixture to allow for maximum efficiency for the load required. Okay, due to the fact of having a FADEC, a number of instruments and indicators will derive. We have these two indicators here. Okay, I want to make a note here. You might have these kinds of indicators. For example, here we have RPM. You might have oil quantity, oil temperature, oil pressure, water quantity, water temperature, or whatever. But these indications might partly or completely be inserted into the Garmin 1000. Okay. Yeah, they'll be showed in the PFD in this case. Okay. So basically, we have the start and master switches. We talked about them before, and the load and RPM indications. Big difference here. What is load, and RPMs? In other systems, we had indications of load. We have talked about it when we talked about the fatigue in the electronic section, but I can remind it again. Diesel engines are going to work on load because the fatigue is going to adjust the RPMs and is going to adjust the mixture to fit the load you are requiring. Okay, the load is going to be presented in a percentage. 90% of the load, 80%, 70%. Okay, that's going to be your numbers now. You're not going to be looking at RPM because the fatigue is going to control them. You're going to be looking at load. So anyway, this big difference between the engines, I want to suggest you that you take a look at the engine section on your manual again for more information, as you might read many interesting data and know much more about the airplane you're going to fly, and that is really important. Now we're going to be seeing the oil system. This is kind of the oil system that we are going to be seeing here. As the oil system is generic and hasn't really changed substantially from the Cessna 172 November, we are going to introduce this general diagram that I made that basically explains the different parts and working principles of the system. All right, so let's begin with it. The first part is the engine and all its parts. Okay, that's our goal. We want to get all the oil to go into this part. So we're just gonna start from there, okay, to keep our goal all the time in the screen. Then we have the sump. The sump is basically where all the oil is gonna come down. Okay, the sump is gonna be that big bowl that is gonna be under the engine, so all the oil that already walked in the engine is gonna be bleeding down inside the sump. Okay, it's like our reservoir or something like that. From the sump is going to be going to the engine-driven oil pump. The engine is driving the pump. Okay, so at any moment the engine is moving, oil is going to be flowing through the system. Okay, that is vital. Okay, we cannot allow the engine to be running without oil pressure. If the engine is rolling without oil pressure, we're going to break our engine in matter of, I want to say seconds, but probably minutes, right? So we want that oil to be flowing all the time. From the oil pump, it's going to go to the bypass valve. The bypass valve is going to decide whether the oil is going to be flowing through route A or through route B. Okay, we have two routes and this bypass valve is going to decide. I'm going to show you now why. It's going to depend on temperature. Okay, here we can see a radiator or a heat exchanger. So basically the oil, it cannot be too hot because then it doesn't cool and it doesn't do its job correctly, but it cannot be too hot either. All right, so if the oil is cold, if the oil doesn't need to be let's say cooled, it can go through this line. Okay, there's nothing in this line. The engine just goes from the pump, goes through the valve, and goes to the rest of the system. But if the oil needs to be cooled, then it has to go through this radiator. The ram air is coming through here and it's going to be cooling the oil, and then it can continue. So we have these two sides that the oil can go through. Then we have the oil filter. We cannot throw dirty oil that might have some dirt on it, metal particles, things like that. We cannot throw that inside of our engine because the engine is a really sophisticated piece of engineering, and if we throw these pieces inside of the engine, we're gonna end up breaking it. Okay, so we want to filter it. Okay, this filter gets changed every 50 hours. That way we make sure that the engine is all the time safe. After that, we have the PRV, or pressure relief valve. Okay, this pressure relief valve is going to activate if the pressure that is coming to it is too big, and it's going to release that pressure inside of the sump without going through the engine. Okay, this is to protect the engine. If we throw too high pressure to the engine, we are going to be breaking the engine. So the PRV is in charge of sensing that oil pressure, and if the oil pressure is too big, it's going to open this side so some of the pressure can escape onto the sump. Okay, the oil that doesn't escape through the sump is going to be thrown inside of the engine and all its parts, and it's going to do its job finally, that is cleaning, cooling and lubricating principally the engine and all the moving parts. Okay, so as a recap in this session, we have learned about the differences between the three power plants that we can find nowadays inside the Cessna 172, and I am absolutely sure that there will be more engines fitted in Cessnas. As I said in the previous lesson, maybe electrical, but these are, or these might be the most typical ones, and maybe that's why we're taking a look at these ones in this course. As we have seen, every engine is different and presents systems depending whether or not need them. Okay, if we have a carburetor, we're gonna be featuring a carburetor heat. If we have an injection engine, we're gonna be featuring more precise gauges. And if we have a diesel engine, the FADEC is gonna need a lot of information. The FADEC is gonna need a couple more associated systems. So there are going to be substantial changes, right? From the older carburetor engines to the newest diesel models, efficiency, ease, and safety of the operation have been increased as a result. I mean, guys, the carburetor engine was good. The Cessna 172 November carries one of the most reliable engines in the world. However, the industry nowadays looks for efficiency, ease of use, and of course safety of operation, and I think these new engines are actually doing the best in increasing these three. So yeah, we have finished with engines and oil system. If you want to know about more systems, go to your page, keep reviewing the systems, go back to the previous slides, keep studying. I'll see you on the next session.